Okay, so we did the law of sines, which, as far as remembering that formula, it's pretty easy. The law of cosines is a little bit different. So the two that we couldn't do with the law of sines, we couldn't do side angle side or side side side. Those were the ones that we couldn't do with the law of sines. So we have to use the law of cosines. Now, same exact thing. You're just, you have a formula and you're plugging it in, and you're solving for those missing sides. The only problem is that the formula is not pretty. So on page 419, if you want to write these down or look at them, here are the law of cosines. So a squared equals b squared plus c squared minus 2. So it's always kind of looks like Pythagorean theorem. And then minus 2, the two angles on the same side, or the two sides, so BC, and then times cosine of A. So you see there's more sides than angles. That's why side, angle, side, 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 side. That's why these are going to be suitable. So that works for all of them. So you would have b squared equals a squared plus c squared minus 2, these two, ac cosine b, angle b, and then c squared equals a squared plus b squared minus 2ab cosine c. Yeah. It doesn't look good, but that's not the point. The point is it's a formula, and if you plug in the values, it will work. Okay? So, excuse me. The first thing we're going to look at is a side, side, side. Okay? And let's do ourselves a side, side, side. Okay. So, let me just slide this up. A triangle has sides, let's see, A equals 8 feet, B equals 19 feet, C equals 14 feet. And we just want to find the angles. Now, some of you are more visual and you would want to actually draw out this triangle. By all means, go for it. A little hint, and I think that you know this, the three angles that are opposite these three sides, we know which ones are biggest and smallest. The biggest angle is always opposite the biggest side, and the smallest angle is always opposite the smallest side. So as we're solving, we should be able to label these just based on what they are. And what we're going to do, any triangle, if it has an obtuse angle, it's going to be the biggest angle. And if it's not and then the other two angles are always going to be acute, because you can't have more than one obtuse angle in a triangle. It's impossible. It would be more than 180 degrees. So you always want to solve, if you have to do this, solve for the biggest angle first, just in case it is obtuse. And since we don't have the triangle drawn, we don't know whether it is or not. So since we're solving, the angle that we're solving for, that's going to be the one that's on the other side. So I'm going to put 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 cosine b. And we're going to solve for that. We are going to, do all the math here, and I think that you guys are very capable of doing that part of it. but if we rearrange this all, we'll get to the point where we have cosine B equals, let's see, 8 squared plus 14 squared. We have to move, so minus 19 squared. We're going to divide by these. Divide by 2 times 8 times 14. And the reason these are switch signs because we moved that because we wanted the cosine B to be positive. Anyhow, regardless, you solve for it, we get about negative 0.45. Okay. So because a little bit of just, some knowledge here. So the graph of a cosine, we know starts here and then is ending here. So if when we're doing a cosine, cosine is equal to something positive, it's going to be an acute angle. If cosine is equal to something negative, it's going to be an obtuse angle, because this is pi over 2, so this is 90 degrees. So this is before 90 degrees, and this is after 90 degrees. You can see positive versus negative. So we can see now that this is going to be obtuse. Anyhow, you do the arc cosine, and we would find that B is equal to 116.8. Now, really, you only ever want to do the law of cosines once, because now that we have an angle, we can start doing law of sines, and it's going to be way, way easier. So if we want to find angle A, now we would do sine A over side A, which is 8 feet, equals sine of B, which is 116.8, over side B, which is 19. And I believe that, personally, I think that this is the way easier formula. So you do this once because you have no other option. And then we revert back to this. Anyhow, cross multiply and then do an arc sine. And we would get, let's see, we would get sine A equals 0.37583. Once you solve. And then, of course, that means that angle A equals about 22.1 degrees. And then the easy part is, well, we know all three angles add up to 180, so subtract both of these, and we will find out that angle C must equal about 41.1. So the formula is more complicated. It takes a little bit more steps to work out, but it's just a formula. You plug it in, you get the answer. It's not bad. And then, like I said, you typically only have to use it once, because then once you get your angle that you need, you can go back to the law of sines, which is definitely, I believe, the easier of the two. Okay, so that was an example for side, side, side. Let's check out a side angle side. And the issue with the side angle side and why we can't use the law of sines is because the sides, it's the wrong side. Oh, excuse me, it's the wrong angle. So, here's our example. Let's see. I'll draw this one for you guys. You're going to get to the point where you don't need to draw the triangles. If you want to, you can have them, but you should, since you have them labeled, you're probably okay without them. So this is angle A, this is side A. Angle A is 115 degrees, 10 centimeters. And this is side C, this is angle C, this is angle B, this is side B, and side B is 15 centimeters. Okay, so here's the issue. We have two sides and an angle. The reason that we can't use the law of sines is because you need a ratio of the same letter. This is angle A, this is side B, and this is side C. So none of the letters are the same. If we had side A, we could do it. If we had angle C or angle B, we could do it, but we can't. So we're going to use law of cosines to find side A. and then you'll have the ratio of side A and angle A, and then you can use law of sines. So, let's see here. It's actually, the law of cosines is actually kind of nice when you're trying to find a side, because it's already set up for that. So a squared equals b squared plus c squared, c squared minus 2 times b times c times cosine of a. That's all you do. All right. So you're just typing that into a calculator, you're getting your answer. A squared is going to equal 451.79. And then, of course, square root both sides, and we're going to get A is about equal to 21.26. All right, that's that. Once you have that side, now we can use side A and angle A to set up a ratio for the law of sines. So 21.26 over sine of 115, because those go together, the side and the angle. Okay. Let's find angle B next. So side B, 15 over angle B, sine of B. And anyhow, you know, cross multiply, and we're going to get, let's see, we'll get angle, I do the math here, but I'm going to tell you that angle B is going to end up equal to 39.75. And of course, then once we have this angle and this angle, we can just subtract to find angle C, which is equal to 25.25. Okay, so you'll only have to use the law of cosines once, and the rest kind of just, you know, it works out nice. Okay, so just do this. We're going to just solve the triangle. You're just getting all the missing sides. So on page 423, just do 1 through 9 odd. Some of them are side, angle side. Some of them are side, side, side. Just kind of, the ones that aren't drawn, if you want to draw them, if you need to visualize it, totally up to you. But anyhow, solve them. The answers are in the back of the book, and send it in. Thanks.